So we should all be fed up of Unidens by now, because this is an Audioline 341, and coming from the same customer as the previous one, he wants this one's capacitors changing as well, and I think we need to do another. We'll use the same bit of paper and we'll see how it performs before we do anything to it. I'll use one of our standard replacement microphones to set this one up. Switch on the power supply. Switch on picture in picture. Switch on the radio, put it on channel 20. Make sure the tone's in the low position, because that affects the synad. Mic gain and RF gain to full. Okay, key up. 3 watts on the dot. So TX power 3 watts. Wallow. Wallow. 1, 2. My goodness, that's quiet. At 0.5. I'm going to just double check that we've got the mic gain up on this. Yep. I'll do second harmonic on the spectrum analyzer. So measure. So it's minus 66. Minus 66 dBm. It needs to be better than minus 74. So that does need improving. So, where else are we? Well, yes, let's put receive. So put the synad meter on. So S9 is showing about spot on. Just need to plug into the external speaker socket and not the PA socket. Turn the squelch down. So about 12 there. It's very good actually. I'm kind of between scales, I must admit. I'll just put it on an easier to read scale. 0.31. Do the 10. 0.25, and we'll do 20. .1. Well, it's so good already. I'm surprised if we're going to get anything better out of this. So I'll pause. I won't pause the video. We'll just we'll look inside the set first, I think, together. So apart from having transmitted deviation as quiet as a mouse, the radio otherwise works quite well. I may as well put the soldering iron on because that's inevitable. Doesn't look too messed with. That's the soldering iron on the floor. That's the soldering iron not on the floor. On the side of the speaker. If this was my set, it'd be having the lids go through the dishwasher, but it isn't my set, so I won't. So once again, we'd have to change that 220 and that 220 because they have become troublesome now, and we'd have to change the 470, those two there. So it's a different layout slightly to the smaller version, but it's electrically the same. So with that, I'll set about changing the capacitors. Okay, so fast forward 40 minutes, we've done all the capacitors, and as before they are all these can't remember the name, Nichicon things, apart from one which we don't have in stock in that make, so we put a high grade other brand in, which is that 0.471, which is now in bright orange. Right, so we'll go into transmit. So I'll put picture in picture on, make sure we're on camera 1. Key up, and where we still have 3 watts, which is exactly what one would expect. So, we'll check the VCO first. So remembering that it's a floating chassis, we'll just connect our negative to the negative rail. It's a bit easier to work on these larger sets. And we want channel 40, and we want the test point just there, and on transmit we should have 3.5 volts. We've got 3.6, so I will just prop that down to where it should be. So having to do everything with one hand. It's just within 0.1 of that. I think we're just about there. That'll do, 3.45. Now we're supposed to have similar on receive and transmit. on channel 1. That looks about right. So go back to channel 20. So if we don't do that, you can end up with channels dropping out at the top and bottom in weather extremes. I can tell this set's had work done, but that's no reason to know that it's not right, because it's certainly working well as it arrived, apart from the deviation. So, transmit. Now dropped to 2.9 as it's warmed up a bit. 2.9. Just make sure the spectrum analyzer's on the right frequency. Just while I'm at it. That's not having effect on there. So let's hope this one does. If we've got a low output, .8. Four. Okay, now we'll look at the spectrum analyzer. Okay, so we've got both of them showing, and like before, we've got equal, so we need to reduce this, but try and retain the kind of power we've got. Okay, so there we are now. There's our fundamental, and there's our interference. So we can now measure that, and it's supposed to be minus 70, better than minus 74. So measure, yeah, so that's absolutely fantastic now. Right. Are we still doing 4 watts? Let's go back to our original meter. And we're doing spot on the 4 watts. So that's an improvement. So let's look at what the meter on the front says. Want it to be in the centre of the red zone, and it's not quite in the red zone. So we will just adjust the meter to be centre of the red zone, which is there. Now we'll check low power. So it should be 0.4 of a watt, so there's 0.5, there's 0.4. We actually have nothing working at all on low power. Now that can sometimes be a dirty preset, sometimes it can be a broken preset. So we'll just waggle that around. There we go, so that's 0.4, so it was dirty. So we'll go back to full power, boing, 4 watts, and we'll do that deviation. I think some of these could do with cleaning. So we get a little oscillator out. So we're doing about 1.5, so just spraying the cleaner into that has brought it back to 1.8 from 0.5. Mind you, changing capacitors might have helped. So let's just try it there. Wallow. That's spot on. 2.2 and 2.5 absolute maximum. So that's deviation sorted. Yeah, it could be the fact we've changed the capacitors in there, which has brought a malfunction back working. To be honest, that's more likely. So now we're done on transmit. So now we'll look at receive. We'll start by putting S9 on the radio. And we're done with the spectrum analyzer. Turn that off. And we're looking at the oscilloscope. So adjusting the detector for the best, highest amount of recovered audio. So there was no improvement there, it was already spot on. So now we'll move over to the synad meter. And we'll park that about 0.4 and see whether we can improve the radio. Put more signal on for that one. I'll try that one left-handed. It's even the ceramic tool's affecting it. So we're at no, it's exactly the same. Exactly the same. Let's have a look. 0.82. I was thinking it's the other set's actually slightly better. It's not. It's hard to change. We've lost a bit of noise there. Right. So we'll take that lid back off, and we'll just check that S9 is S9 on the meter. It isn't. So just sort that out. Signal meter is that one. And then we need to do the squelch. So I'll turn the squelch to full. Whoops, that's the volume. Squelch to full. Let's select. I'll go onto the other camera and then we can see what I'm doing. And so we're going to park the signal. We've got the signal generator on, and we're going to put it to 100 microvolts when I want the squelch to come in. It isn't coming in, so let's look where it is. That's 100 microvolts, 300 microvolts, 1 millivolt. So I need it backing off. So with the squelch preset, we'll back that off. Now that's 30 millivolt, 100 millivolt, microvolt, sorry, 30 microvolts, 100. That's where we want it. Now then, we'll turn the squelch, oops, that's the volume. We'll turn the squelch to off. Now where's it gone? That was mic gain I was fiddling with. So we'll switch the signal generator off and set the squelch threshold. Switch the signal generator on, and let's see where it comes in. So it's coming in at 0.51 of a microvolt, and it's going off at 0.41 of a microvolt. So we've got the right kind of sensitivity that we're looking for. But the exercise did not change the sensitivity. It's lost a bit of noise, and I think we've improved the. Of course, we've improved how many years this thing's going to work for. So we've got a full 4 watts. Let's go back to that first meter. Well, it's about 3.7 at the moment. And the power supply's dropped 0.1. Now, yesterday's set was 850 milliamps. Let's put this power supply back. 3.7. Was 850 milliamps for the 4 watts. This set is 1.17 amps for 3.7 watts. So there you go. We're not going to touch the power output any further because, as you know, we had to reduce that rather large second harmonic. So that is how it stays. At least he's got the power where it's supposed to be and not coming out on somebody's television set in Germany. So that's another one done. So put it back together and we'll see if there's anybody actually out there, which I highly doubt. I always re-tin these. As ever, I'm trying to put the lid on the wrong way. Okay, so in conclusion, let's just see what the power's now doing from cold, about 3.7 watts. So let's put it into our special Zetagi wattometer. Because Zetagi watts are different to real watts. And how many Zetagi watts have we got today? Oh, it's good. It's doing 5 Zetagi watts, so I'm glad about that. Because I'll tell you what, if it's doing 3.5 Zetagi watts, it needs repairing. Right. So the conclusion. This radio was working virtually perfect. Well, no, the receiver was working very well, and there's a but to that in a moment, which I'll come to. So yeah, we've improved the 20 dB, 12 dB remains the same, 10 dB. You know, it's neither here nor there, but we dropped the noise. In my jar of bits, we have one of the IF coils. I've had to nick that off a scrap chassis and replace it because I just could not get the detector to stay in one place. You tuned it for 100 microvolts for S9, beautiful on the detector, and then you went down to something like 1 microvolt It was all wishy-washy, and you could reset the detector, but it was the previous coil that just wasn't reacting properly. So I got a scrap chassis, so taking that off there, and that's what's in this set. So it was funny when you're in the 1 to 3 microvolt range, so that would have been really, really weird. So we'll just see what it sounds like. Put our aerial in. Should have done this with on the dummy low, to be honest. We'll just listen on our monitor receiver. Testing 1 2, testing 1 2 3 4 5. That's fine. See if anybody is out there. One niner, Roger. They're all having their tea. Their mummies have called them in. Alright, we'll do an on-the-air test with that later on with Mr. Chippy. And it's the York 863, I think, tomorrow. Oh, yeah. So, Quotages said to me, how about doing a recap of Fidelity 1000 or GT 868 chassis or something like that? I thought, what a good idea. So I've ordered some parts to do that, and we will do that when they arrive in a few days' time. Just for a laugh, you know. It'll still be a bleed over box, but it might be a better quality bleed over box. But when I started ordering the capacitors for the radio, what did I discover? The VCO, with all that sensitive, you know, stuff which you don't want to be having malfunctions in, they're all tantalum bead capacitors already in there. And my experience with tantalum bead capacitors is they either work or they don't work. They go up with a lovely puff of smoke if they fail. So that's some I don't have to replace on that set. So there you have it, a rather splendid Audioline 341 from 1981. Thank you for watching.